Section 2.5 is on derivatives of our trig functions. And so we are going to start just right there. And we're going to do some examples. And we're going to start, though, by looking at what are the derivatives of the 6 trig functions. And we're not going to prove all of them. We'll prove a couple of them. So let's actually just start with one of those. So let's take a look at showing what the derivative, what the derivative with respect to x of sine of x. So let's start with that one. So like most of our proofs, we start with the definition, the limit definition of the derivative function. So the limit as h goes to 0 of sine of x plus h, so there's our f of x plus h, minus our sine of x, so there's our f of x, all divided by h. So of course the main issue right now, if you sub in 0, we get our good old 0 over 0 indeterminate form. All right, so where would we go from here? Well, I hope you remember the thing not to do, which is in trig, if trig was nice in terms of behaving, let's say, according to like certain algebraic rules that we wish maybe were true, like sine of x plus h being sine of x plus sine of h. If that was the case, you wouldn't have whole pages of identities and a whole course in trig, and if it was that easy, right? So I don't expect that you'd have this one memorized. I don't. There's a lot of, sum and difference and sum to product, product to sum. There's lots of those identities, but I just would expect that you know that there is an identity out there and to not make it sine of x plus sine of h. So we would reference our identity sheet and say, well, what could I do with sine of x plus h? And that is equal to sine of x cosine of h plus cosine of x sine of h. And then, of course, we still have our minus sine of x, and that all is divided by h. All right, so now we're just going to do a little bit of algebra here, and I'm going to reorder a couple of terms and then factor out sine of x. So I'm going to say, all right, this is sine of x, cosine of h. Let's just switch and make that minus sine x, and then plus the cosine x sine of h. So I'm just going to reorder a couple of terms there. And now what I want to do is factor out sine, and at the same time I'm also going to rewrite this as two different terms. So we have the limit as h goes to 0, and I'm going to factor out the sine x from the first two terms, so cosine of h minus 1, and that is over h. And then I'm going to break this into two terms where I'm going to write the last term, cosine x sine of h, all over h. All right, now remember, when you have a limit of a sum, properties of limits say you can take the sum of the limits. And as we take a look at what we have the limit as h goes to 0 of sine of x times the cosine h minus 1 over h. And then we have plus the limit as h goes to 0 of the cosine of x times the sine h over h. And if you look at, in the first term, sine of x, that is something that can be brought out in front of the limit because it doesn't have an h in it, so it's not going to be impacted by the limit as h goes to 0. So we can maybe just even bring that out in front as a constant multiple. And then the same thing in the second term with the cosine of x. Now hopefully these two limits look familiar. So we proved these in the last chapter. So the first one that we proved was the limit as h goes to 0 of sine of h over h. So we proved this one first, and that went to 1. And if you remember, this was what we proved by good old squeeze theorem, if you recall that. And then as a corollary to that initial proof, we showed that the limit as h goes to 0 of cosine h minus 1 over h, that goes to 0. So of course that's going to mean the first term just becomes 0, and my second term here is all that's left, cosine of x times 1, which of course is just cosine of x. So we've just shown that the derivative of sine of x is equal to cosine of x. Now, of course, the derivative for cosine of x would follow very similarly, so generally we'll show 1 or 2 of these, but we do end up with a kind of a negative sign in that situation. So the derivative of cosine is going to be negative sine. And then when you get into some of the other ones here, so let's just, actually, I'm going to squeeze this in up here. So my final answer here, this was equal to cosine of x. All right. So now suppose that I wanted to prove, let's do another one here. Let's say we take a look at showing the derivative, this time with respect to x, of tangent of x. And so in this case, once we've shown sine, and cosine would follow similarly, you know, a lot of these you could do now because you can always rewrite all of the remaining trig functions could be written in terms of sine and cosine, and now you know quotient rule. So following quotient rule here, what we have is our denominator left alone, and then times the derivative of the numerator. So the derivative of our sine, we just showed, that's equal to cosine. Minus, and then changing the order, so now it's the numerator left alone, times the derivative of the denominator, and the derivative of cosine becomes minus sine. We didn't prove that one, but it follows really similarly. And then this whole thing, of course, gets divided by your denominator squared, so cosine of x quantity squared. So what do I really have here? I have cosine squared of x, now plus sine squared of x, and that is all over cosine squared of x. And hopefully you remember sine squared plus cosine squared. That's the most common form of that Pythagorean identity. That's a really common remembered one. So that's equal to our 1. And 1 over cosine squared, that reciprocal, is of course secant squared. And so that is the derivative of tangent. So the derivative of tangent, going back up here, that's our secant squared that we just showed. So this is going to be secant squared. And so I'm just going to fill in the other ones. Cotan you would do similarly. You'd end up with negative cosecant squared. And you could rewrite secant as 1 over cosine and do something similar. This one ends up being secant x times tangent x. And the derivative of cosecant becomes negative cosecant x cotangent x. So those are the derivatives of your 6 trig functions. So let's take a look next time. Actually, I think I'll stop this video, and next time we will come back and start to take a look at a bunch of examples.